Okay, so I had 11.1, which was the fundamental counting principle. Some terminology that you need to know from this section. The first one is the fundamental counting principle itself, which is the number of ways in which a series of successive things can occur, and it's found by multiplying the number of ways in which each thing can occur. So an example of this would be you go to Cracker Barrel, or you go with your friends and your family, and you have a choice of 18 vegetables, 3 choices of meat, and 4 desserts. So how many different 3-course meals could you possibly choose? So you use the fundamental counting principle and you multiply each choice that you have to get your total number. So you take 18 times 3 times 4, which gives you 216. The next term that you need to know from 11.1 is the tree diagram. A tree diagram is used to show all the possible outcomes of an event. So an example of this would be, it's your best friend's wedding day, you're attending her wedding, and you have 2 dresses and 2 pairs of heels to wear. What are your possible outfits? So you have over here, here's you, and you have a green dress and a blue dress. You have some green heels and some blue heels. So basically you just draw it out. Off of that you can do the green on green, blue on blue, green on blue, and blue on green, which gives you a total possibility of 4 outfits. Okay, so the next session I had was 11.2, and the terminology you need to know for this was permutations. A permutation is an ordered arrangement of items that occurs when no item is used more than once and order does matter. The formula for this would be NPR with n factorial over the quantity n minus r factorial. An example of this would be that you have 25 people in your freshman class running for president, vice president, and treasurer. The orders in this matter, so you're going to use a permutation and not a combination. You're going to take the formula that you just learned, and with 25 people available and r being like the number of spots you have, you're going to take 20 factorial over 20 minus 3 factorial. And once you put this in your calculator, you'll get the answer 6,840. One of the last terms you need to know is factorial notation. If n is a positive integer, the notation n factorial is the product of all possible integers from n down through the rest of them. So you'll have n factorial minus n, and then it goes just so on and so on. So an example of this would be 4. So you have 4 factorial. So you're just going to multiply 4 times 3 times 2 times 1. If you had 5, it would be 5 times 4 times 3, and so on. A note that you need to make a mental note of is 0 factorial, by definition, equals 1. Okay, the last thing you need to know is permutations of duplicate items. The number of permutations of n items where p items are identical, q items are identical, r items are identical, and so on. So this would be an example where you have a word with multiple repeating letters. So the best example is Mississippi. So you have 4 I's, 4 S's, 2 P's. The total number of letters that you have is 11, so you'll have 11 factorial over the repeating numbers that you have. So you'll have 4 factorial, and 2 factorial. You'll type this into your calculator with parentheses. Don't forget parentheses around the top and the bottom. And that concludes 11.1 and 11.2.